This is the question of SSB 2023 metric space. Question number 22. If D1 and D2 are matrices on non-empty set X, then which one is true? We have to verify which option is correct. D1 into D2 is metric. Option B said that D1 plus lambda into D2 is metric if lambda belongs to real. Okay. Third option given that minimum of D1 comma D2 is a metric, and last option said that maximum of D1 comma D2 is a metric or not. We have to verify one option then another option. Okay. First we have to verify product of two matrix space is a metric or not. We know that when D1, what is the metric? What is the definition of metric? D is a mapping from X cross X to R is said to be metric space. Is said to be metric space if it satisfies three properties. Number one, D of X comma Y is equals to D of Y comma X. This is symmetric property. And second property, D of X comma Y is always greater than equals to 0 for all X comma Y belongs to capital X. And third property, this is triangular inequality property. D of X comma Y is less than equals to D of X comma Z plus D of Z comma X. So we have to verify these three property for each option. Okay. First of all, we have to verify option B. What is given to us? We have to verify first option B, that is D1 of plus lambda into D2 is metric or not if lambda belongs to real number. Okay. If D1 is a metric, so D of X comma Y is always greater than equals to 0 for all X comma Y belongs to capital X. Similarly, D2 of this one D1 of X comma Y and D2 of X comma Y is always greater than equals to 0 for all X comma Y belongs to capital X. Okay. If we multiply, if lambda into D2 of X comma Y, if we multiply lambda with D2, then it may be negative if lambda is negative. If lambda is negative, D2 of X comma Y is negative. So D1 plus lambda D2 may be negative. So option B is cancelled. Okay. Our second property does not hold here. So option B is wrong. Next we have to verify our first property. Product of two matrix space is a metric or not. We have to verify option A now. Okay. Let D be a metric. We have to define a metric. D be a metric such that we have to define D1 and D2 two matrices such that D1 is equals to DFF A comma X comma. How can we define it? DF is a mapping from X cross X to R such that X equals to, suppose I take only A, B and C. Okay. X equals to only A comma B comma C. Okay. Similarly, F is also is F is a mapping from X to R and G is also a mapping from X to R, and DF comma DG DG is equals to DF. How we define the metric DF? DF of A comma B, we can define this one equals to mod of F of B minus F of A. Okay, we can define in this manner. DF equals to this much and DG also similarly. Similarly, DF equals to DF of A comma B equals to modulus of F of B minus F of A. Similarly, DG of A comma B equals to G of B minus G of A. Okay, how we define F and G? Now we have to define a well-defined function F and G. How we define? Let us take. Okay, F of A, suppose, let we define in this manner. F of A equals to how much? F of A equals to 0. F of B is also equals to 1. F of C equals to 3. Okay. Similarly, G of A equals to 0. G of B equals to 2. G of C equals to 3. Okay. We define in this manner. F of A equals to 0, F of B equals to 1, F of C equals to 3, G of A equals to 0, G of B equals to 2 and G of C equals to 3. Okay. Now, we find DF of A comma B, DF of B comma C, DF of C comma A. Okay. DF of A comma B is equals to how much? F of B minus F of A. What is the value of F of B? We take F of B equals to 1. So 1 minus 0 equals to how much? 1. Similarly, DF of B comma C is equals to F of C minus F of A is equals to how much? This one equals to B minus C minus B. F of C minus F of B, this is equals to how much? What is the value of F of C? F of C equals to 3. This is minus 1, which is equals to 2. DF of C comma A is how much? DF of C comma A is equals to F of A minus F of C modulus. Value is how much? This is 0. This is 3. So 3 minus 0 is how much? This one is 3. Okay. Similarly, you can verify DG of A comma B is how much and DG of B comma C is how much and DG of C comma A is how much. A comma B, DG of A comma B is how much? DG of A comma B is equals to 2 and DG of B comma C, G of B minus G of C is equals to how much? This one is value is 1 and the value of this one is equals to 3. Okay. Now we have to find the minimum of DF and DG. Okay. If you take this one equals to D1 and this is equals to D2. Okay. This one is D1 metric. This is D2 metric. You can verify this is a metric space. DF of A comma B is always greater than equals to 0 and symmetric property also hold, and you can verify here triangular property is also hold. So all properties are hold here. So this is also a metric. D1 we can consider D1 is a metric in this manner and D2 is a matrix as like this manner. So now we have to verify D is a metric. D equals to how much? DF cross D2. Okay. D1 cross D2 which is equals to DF cross D2. Okay. Now we have to verify this is metric or not. Let D be a metric. This is equals to D1 cross D2 which is equals to DF cross dg. So d of a comma b is equals to df of a comma b cross dg of a comma b. Okay, df of a comma b is how much? df of a comma b equals to 1 and dg of a comma b equals to how much? This is equals to 1 cross 2 and value is also 2. And similarly d of b comma c, which is equals to how much? df of b comma c cross dg of b comma c, and value of this one equals to how much? df of b comma c is how much? This is equals to 2 and dg of b comma c is how much? dg of b comma c equals to 1. The value is also 2. Similarly dc of c comma a equals to df of c comma a cross dg of c comma a, and value of this one equals to how much? 3 cross 3, which is equals to 9. Okay, we can easily check here that d of c comma a is equals to 9, which is not less than equals to d of c comma b into d of b comma a. Okay, this one is how much? This one equals to 2 and this one is also 2. d of b comma c equals to d of c comma b. 1 cross 2, 2 cross 1 is always 2. Similarly d of b comma a, d of b comma a is how much? This is also 2. Okay, so d of c comma a, d of c comma a is not less than equals to d of c comma b cross d of b comma a. So triangular inequality does not satisfy here. Not satisfied. So option A is also cancelled. Last third option, we have to verify minimum of d1 comma d2 is a metric or not. Now we have to verify option C. We consider same example as like d1 equals to our df of a comma b and dg equals to our d2. d1 equals to df and d2 equals to dg. We have to verify minimum value. Minimum of df comma dg. We have to verify this option. This thing, minimum option C here given that minimum of d1 comma d2 is how much? We have to find. This is a metric or not. Let this one equals to d. So d of a comma b equals to how much? Minimum of df of a comma b comma dg of a comma b is equals to how much? Minimum of df comma ab equals to 1. Minimum of 1 comma 2 equals to how much? This one value is 2. Similarly d of b comma c equals to minimum of df of b comma c comma dg of b comma c is equals to how much? Minimum of 2 comma 1. Okay, which is equals to also 2. And similarly d of c comma a is equals to minimum of df of c comma a dg of c comma a, which is equals to how much? Minimum of 3 comma 3 equals to 3. Here 3 is d of c comma a. Okay, d of c comma a is equals to 3, which is not less than equals to d of a comma b comma c. Okay, how much? This value is 2. We have to verify minimum value. Sorry, this minimum value is 1. Na? Sorry. minimum value of 2 comma 1 equals to 1 and minimum value of 2 comma 1 is also 1 and d of a comma b equals to 1 plus 1 is equals to 1 equals to 2. 3 is not less than equals to 2. So our option C is also cancelled. Okay, minimum we have to, how we verify? We take d1 equals to df, d2 equals to dg. As like we take in option A, similar construction. Okay, df of a comma b equals to f of d, modulus of f of a minus f of b equals to 1. Similarly, df of b comma c equals to modulus of f of b minus f of c, which is also 2. And similar manner we have find here d of a comma b equals to minimum of these two value. Minimum value is equals to 1 and here minimum value is also 1 and here minimum value is how much? 3, and 3 is not less than equals to 2. So our triangular inequality third property is not hold here. So option C is also cancelled. So according to our question, option D is true, which is remaining option. So option A, B and C is always wrong. Product of two matrix is not a matrix space. Scalar multiplication is a matrix space when the scalar belongs to positive real number. And minimum of d1 comma d2 is not a matrix space. Always remember, maximum of d1 comma d2 is always a matrix space. Okay.